Hey everyone, Chip Plus from LCI Corporation here. Today I want to talk to you about thin film dryers and how they can help solve the current biosolids challenges we are facing. As an industry, we're facing a myriad of biosolids challenges right now. I've put just a few of them up on this triangle, and I don't have time to talk about each one of them, but the one I want to talk about is sustainability. We need to find processes that are sustainable not just for today, but into the future as regulations change and as disposal avenues dry up. So how does a thin film dryer help us achieve sustainability? It's by flexible drying. I've placed a few of the different applications that a thin film dryer has been placed into on the screen. But the even better news is that same thin film dryer can be used for one application today and another one tomorrow. So let's say today you need a Class A agricultural product. We can do that. Then let's say in the future, due to some regulation, you have to send your sludge to a landfill. We can do that. Then let's say in the future you want to go to thermal destruction or add some digestion to your process. We can do that as well. So as you can see, the same dryer over its lifetime can fit whatever biosolids process you need it to. So how does a thin film dryer fit all these processes? It's by its ability to partially or fully dry sludge anywhere from 30 to 95% DS using the same dryer. We can also add in secondary drying or pelletizing to get you the product characteristic you need. Let's talk about Shanghai, China. This is an incineration process, but it's a co-incineration process. They're still looking at partial drying as they're only trying to get the solids up from 20 to 70%, but in this case it's not used for fluidized bed incineration, but used more for a municipal waste incinerator. We use both our thin film dryer and a secondary linear dryer here, and this is designed for each drying system to evaporate about 10,500 pounds of water. Now let's talk about a very interesting installation in Middlesex County, New Jersey. In 2008, they installed 5 thin film dryers designed to dry sludge up to about 50% solids. This was used to reduce the volume of sludge that they had to send to their lime stabilization process. Not only was the amount of sludge reduced, but also the amount of lime used as well. In addition, they saw a significant reduction in the odor of the disposed of sludge. Each of these dryers is designed to handle about 18,000 wet pounds an hour of sludge and evaporate about 8,500 pounds an hour of water. Let's talk about Gifhorn, Germany. In this process, we're drying THP sludge from a CMP Pondus system. We're using a thin film dryer followed by a linear dryer, and we're taking feed solids up from 25% up to a maximum of 80%. This is an interesting application because THP sludge has been notoriously hard to dry because it creates a lot of dust. But in this process, with the combination of the secondary linear dryer, we have a nice granular product with very low dust. Finally, let's talk about Neuberg, Germany. In this application, we're using a thin film dryer followed by a linear dryer in order to fully dry sludge up to about 90%. The end product is then used as fuel for a cement kiln. This dryer application evaporates about 2,600 pounds an hour of water. Thank you for watching our video on sustainability and flexibility of the thin film dryer. If you have any questions, please reach out to me on the contact information provided. Also, please like, subscribe, and follow our social media.